Hello guys, so in this video I will instruct you guys how to conduct for the hypothesis testing on Excel based on the hypothesis that we already know about the population standard deviation, or we can say the hypothesis sigma none. Alright, to do this we first of all go into Canvas, okay? And you can easily download for the sample datasets. Just come in from the same website, the module datasets number 9, chapter 9. So after when you already just extract it into your local computer, there will some datasets could be displayed on your window. However, in this example, we will first of all go with the hypothesis sigma none file. When we open it on, it's going to look like this. And this could be the observation of 50 in total of the observation. We illustrate this based on the McFly's goal bar distance in the example of the section 9.3. And to do this, we make some kinds of hypothesis about the information about the population standard deviation had been none and be assumed to be 12. That in some other way that means the population variant will be also like 12 square. That means 144. Okay, so that means population of the standard deviation has been SDVs of the population. E9, okay, based on the historical data, and that means, in other words, the population variant, okay, have been none too, and they would be 122 square 144. Okay, so now let's go and test for the hypothesis of the non-hypothesis x0. That means the mean of the population will be equal to 295. So in opposite, that means in the alternative hypothesis, the mean of the population will be different to 295. Okay, to do this, I will just illustrate everything on two ways. The first way will be how we conduct and do all the everything based on the manual calculation on the function of Excel. However, in another way, we can go and use the data analysis bottom and the data analysis tool to just find it and show it scientifically and easily. But first of all, let's talk about the situation of the hypothesis first. So over here, just imagine about this could be the distribution of the population, and because that when the people have already provided about the population standard deviation, that means this could follow for normal distribution. Okay, with here we try to just show it into the standard normal distribution with the mean of 0 and of the mean of like 1. Okay, like standard deviation will be equal to 1. And to do that, we first of all have to measure for everything. First of all, remember about the sample size. Yep, that will equal to 50. You just need to use the count function to do that. Another one, sample mean, easily can calculate by the average function, right? And you select for all the data available. That should be 297.6. The hypothesized values has been already listed like 295. Significant level just be 0.05. 0.05. Standard error. Now, how we gonna do it? Remember about the function of standard error. That will equal to the standard deviation divided for square root of the sample size. Remember? Okay, so now that's what I'm gonna do. I take for the population standard deviation already none, divide for the square root of the sample size 50, and that's how I got for the number of 1.70. Okay, I just try to round it and just stop with it in like 2 decimal after the point, and that will be the point. Test statistic of z or z star. How we gonna do it? Remember about the z star. That will be the difference between the sample mean, okay, and this hypothesis values. We divide also for the standard error. Remember about this kind of function, and you got the number of 1.53. Okay, now let's come back into what you're gonna do. Okay, so for example, if we really already standardize into the z-score, so now over here, okay, just think about this way. This could be 295. Okay, this will be 295. Alright, I will just clean this one to make sure that you understand. This will be just normal distribution, but no longer like necessary. Okay, so yep, I'm done with this one. Let's come back into this one. Okay, and think about now the points of the two. I will change the color a little bit. So 297.6 based on the test statistic of z, so they will be far away from the center of 295, 1.53 times of the standard error. Okay, you got it? So basically, when the people say like we try to just kind of reject for the null hypothesis, that means the mu over here, right? There should be somewhere in very far from the 295. It's and it's different. That means in both sides it will be very far from 295 on this side of the right side, or maybe it will be on the left side. Okay, very far from 295, and because of for the normal distribution, they will be what in some way will be symmetric. So it would be minus 297.6 over here too. And for this area, like I call, if this one will be A. Okay, so this one will be A star, for example, and they will be the same. Okay, that will be the point. So I need to calculate for R, for A, and then the areas of A star. So in total, I just have to time for 2 to get for all the area that the probability of the mean, the mu, that means the population mean, will be very far away from the 295. Okay, so to do that, I will have to measure for this area first, the areas that in there, or the right side, sorry, or the left side of the critical value of 297.6. And to do that, I use the function called norm as distribution. That means normal standard distribution, standard normal distribution, and we just need to put in z values. That will be this number. And of course, to get for the p values, this means here the probability that the mu, the mean of the population will fall to the area less than 297.6. okay, this will be probability. So to measure for probability of the mean of the population will fall into the area that will be more than, larger than, whatever. That means this will be 100% minus for this one. Okay, to do that, or you can put them into the very normal number. Okay, alright, and finally, would mean the probability of the two sides A and A plus. So the probability of the two sides will equal to 2 times for the probability of the one side only, and this will be the number. Okay, so this will be in something like p-values of two sides. Okay, and based on this one, because the p-values to tell, okay, to tell over here is, let me see, is equal to 0.1255, and it's larger than their significant level of 0.05. So I can include that, like I can conclude that. What will be the conclusion? I can conclude that we will fail to reject the null hypothesis. Or does mean mean a population is still equal to 295. Okay, that should be the point. However, when we do it all, run everything on the manual way like this, it's be not so convenient. And I show you how to do it when we conduct the illustration on data analysis. Okay, so how we gotta do it? Just with dim1, we create, unfortunately, when we create and use for the data analysis bottom of this one, we have the z-test with the two sample for the mean, and we need two variable 1 and 2 when we really don't have another variable. So it's going to be easily can be solved by you and create for another dummy variable, and you just put in like 1 0 number only, and we assume that this will be the variation of this one will be very small. And now let's go and conduct it. Z-stat, right? Variable 1, that's be our main variable. Variable 2, just try to make it up and use the dummy variable. Okay, hypothesize mean different. Let's take it to 295. Variation of the 1 been none already, and I create and download it, so it should be what? 144. And variation of the two variable of the second variable, the dummy variable, I would just try to make it very small to just minimize for the impact of it. Label in the first round just to let it know that the variable has the name on the beginning observation. It's not the number. Output range, I would just create over here, and I say okay. Alright, for dummy variable, it's not really necessary. You can delete it, and you see all the hypothesis testing for this one. Okay, and just look at this. this would be the p-value for two-tail, and actually, right, they're very close to what we are doing. This is the z-score, and they very close to what we're doing and measure already. So we see that's the p's values, or that means the probability of z is smaller than a specific number of the 1.52, and this will be very small. This will be 2 tau will be 0.29, and we can one more time make all the calculation and also the measurement based on this one. Just remember about in this case, you have to be very careful if the question that's provided will be about the 1 tau or the 2 tau. Okay, second of all, I will illustrate for you guys about the case in which we don't have any kind of idea or the historical assumption about the population mean. That means in terms of sigma has been unknown, and we use for another data set, that means hypothesis sigma unknown operate on, and we see all the data like this one. Okay, so for the same thing, we can conduct everything else like in the other ways, like for all the calculation about the number of observation, the mean by average, okay, and also for the standard deviation. Remember about over here, we don't know about the futures, about the population standard deviation. So that means we use the sample standard deviation instead, and you just need to use for SDEV.S and select for all the data. Okay, and this should be available and come back into like this one. Hypothesized values is over here. They do it for the Heathrow's airport rating something, and basically they have the level of significance equal to alpha equal to like 0.05, and they try to just test it with the null hypothesis will be like for the mean of the population could be smaller or equal than 7, and for the alternative hypothesis, that means the mean of the population could be larger than 7. And just think about this way. Okay, so standard errors, I would do the same SQR, the standard deviation, then we divide for the SQR of the sample size. Okay, you got it, the same number. Okay, and you can do it and test it for the same way. T-test or T-statistic, thus we mean equal to, one more time, the sample mean minus 4 the hypothesized values divide for the standard error. That could be the point. And finally, the degree of freedom, thus you equal to the sample size minus 4 1. Okay, that could be the point. And because I want to say the time over here, I will just show you will be the function about GT distribution and how you measure it all on this one. Basically, with this function, we have the idea about we try to just measure it within T like student distribution, right? With the mean values over here, that should be 7, and we have the mean of the standard deviation, mean of the sample will be 7.25, and we want to check it like if the mu that should be very large compared to the 7 point, like the number 7. Okay, so if you really want to check it and make sure that the values of that will be larger than 7, it's not smaller or equal than 7, that means it must be very large and will be falling into some of the play like this, right? Compared with the 7.25, that will be about 1.8041 times of the standard deviation. Okay. right? So that should be the basic idea we're gonna do it. So we first of all measure for this area, and then second of all we measure for this one, like by taking 100%, and then we minus for this area first. Okay, that should be the point, and that should be basic idea behind that one. And you can easily measure it on for like over here the upper tail, that should be 0.0353. So we can just make some conclusion quickly, like because the p-values of the t-test for upper tail, okay, were equal to 0.0353. That means smaller than 0.05. That should be the level of significance over here. Okay, you can do it and just transform this over here and do this one more time. So we get the conclusion that the non-hypothesis could be rejected, and we accept the alternative hypothesis. Okay, so mean of the population is larger than 7. That should be the alternative hypothesis. And of course, in another way, we can one more time use it for the data and data analysis. And because it's over here, we don't have the kind of like one sample of the mean. Okay, so we have to just use kind of like small trick by use the t-test of 2 samples assuming for unequal variance. But however, to do that is you have to do some trick, because we need the 2 variables at the same time. I one more time create and use for the same trick what I already do before with the previous example. I create a dummy variable of 0, 0 something, kind of that. Okay, as that analysis, I will do it with the same, but now I have the variable 1 already, and the same with variable 2 already. Okay, hypothesis mean difference will be 7, right? And label for first round alpha will equal to 0.05. Remember, in case like they provide for another level of significance, you have to change it, because red one does bondly. Sorry. So output range, I wanna just add it over here or over here, whatever. It will be fine. Let's say okay, and this will be what it is. I will delete for the dummy to make sure that you guys just concentrate on this one. And remember about, in this case, we just care about the upper tail, right? The upper tails of the distribution. So we just need to do it and check it over here. Alright. And you see it's totally the same with what we have already calculated before. So we can make the same conclusion as this one. P-value of the t-test for the upper tail were equal to 0.053, and is smaller than 0.05. So we can reject for the non-hypothesis and accept for the alternative hypothesis. Thank you so much. So throughout all the instruction, I will already show you about in case like we don't know about the population standard deviation. And we already demonstrated how you can measure all the things based on the manual calculation and also for data analysis tool. Of course, when the data is available, this will be of course better for you to just use the data analysis tool and run it on automatically. And the same thing with the in case like hypothesis sigma unknown, and you can do for the both way will be fine. But in case like I recommend you guys, in case like we have the data available like this, it should be better for us to just run everything one more time on the data analysis tool. And this will be the end of the instruction video.